prove that GCD equal prove that GCD AC equals GCD BC equals 1 if and only if GCD ABC equals 1. Okay, let's start off with the left to right direction. So, excuse me. Well, okay, we'll do the usual trick that seems to be working quite well. Saying A is a product of primes, Pi alpha I. B is a product of primes, and C is a product of primes. So GCD AC equals GCD BC equals 1. GCD here, that's the product of primes, and it's the minimum power. So that would be minimum alpha I gamma I. That should equal the product of Pi minimum beta I gamma I. And that equals 1, which is product of primes, 0. So we have the minimum of alpha I gamma I equals the minimum of beta I gamma I, which equals 0. So that means one of these must be 0 and one of these must be 0. So perhaps, I don't know, maybe a product might be the best way. So that means alpha I equals 0 or beta I equals 0. Alpha I equals 0. No, it can't be or. I guess it could be, but I mean, if gamma was 0, then it'd be job done. What am I trying to get to? That so alpha plus beta equals gamma. Maybe I should do it as products, because I was thinking another way to say this is that alpha I gamma I, like one of these has to be 0. That has to equal beta I gamma I, which has to be 0. So I guess I could also write that as alpha I minus beta I times gamma I equals 0. I'm going to do my little trick I sometimes advise students, which is when you're not sure which way to go on a proof, start at the end and then see if you can connect up with this one. So at the end, we would have had GCD ABC equals, oh, what's wrong with my computer? ABC equals 1. That would have mean the product this one here, that's GCD, product of primes alpha I times a plus beta I, and that one's the product of primes gamma I, that's equal to 1. So that would have meant that the minimum of alpha I plus beta I gamma I equals 0. So one of these is 0. So that means alpha plus beta times gamma equals 0. Oh, I guess I could add these together. Because if you think about this as two equations, alpha I gamma I equals 0, beta I gamma I equals 0. So adding, we get alpha I gamma I plus beta I gamma I equals 0. And then if we factor out the gamma I, we get that. Yeah, I guess that works. Now, do I need to do the proof again for the opposite direction, or is this proof reversible? Let me think. So that there to there, we can go both directions. That seems fine to me. And there to there, that's both directions. That seems fine to me. And to say all of these alpha, beta, gammas are positive. To say that the minimum here is 0 and that's product is 0 means one of these is 0. So we can get that here. And then instead of factoring out, if we're going backwards, we would then say expand. So we would get to here. Now, I think this is where we need a little bit more if we're going backwards through the proof. So since alpha, beta, and gamma are all greater than or equal to 0, we can then go back to this. So that is the only point in reversing the proof to get the if and only if, the both directions. That might require a little bit more explanation. And likewise here, we just change the word instead of saying factor out, if we're going backwards, we're expanding. So that's a little small difference going backwards. If they're equal to 0, yeah, that can go there, and that can go there, and that can go there. So that's expand if we're going backwards, and just write note there then. Yeah, so I'm happy that we can go both directions here. I'm not 100% satisfied with this proof. Got this niggling feeling inside me that I've some sort of problem with my logic somewhere, but I don't know. It seems to work. I just really didn't like this adding step. That's the only step I'm not happy with. I don't know why, but anyways, okay, that's 26 done.